Good day, learners. Today, we are going to calculate the Pearson's correlation coefficient and solve problems involving correlation analysis. But first, what is Pearson correlation coefficient? Pearson correlation coefficient, or Pearson's correlation coefficient, or Pearson's R, is defined in statistics as the measurement of the strength of the relationship between two variables and their association with each other. In simple words, Pearson's correlation coefficient calculates the effect of change in one variable when the other variable changes. What does the Pearson correlation coefficient test do? First, it looks at the relationship between two variables. It also seeks to draw a line through the data of two variables to show their relationship. The relationship of the variables is measured with the help of Pearson correlation coefficient calculator. This linear relationship can be positive or negative. Example of positive linear relationship is, in most cases, universally, the income of a person increases as his or her age increases. Example of negative linear relationship. If the vehicle increases its speed, the time taken to travel decreases and vice versa. So, the formula for Pearson correlation coefficient is shown, where n is the number of pairs of scores, summation of xy, the sum of the products of paired scores, summation of x, the sum of x scores, summation of y, the sum of y scores, summation of x squared, the sum of squared x scores, and summation of y squared, the sum of squared y scores. Example: a researcher wants to find out the strength of relationship between the age and income of the four individuals determined through simple random sampling. First, we have to create a Pearson correlation coefficient table, as indicated below. So there will be a column for the age, the income, for xy, x squared, and y squared. Second, we have to use basic multiplication to complete the table. So for example, the data for the age and income was shown below. To get the value of xy, we have to multiply the value of the age and the income. And to get the value of x squared, we have to square the value of the age. And to get the value of y squared, we have to square the value of y, or the income. Third step, we have to add up all the columns from the bottom to the top so that we will arrive with the total. Step 4, we have to use the correlation formula to plug in the values. So by using the formula, we have to substitute the values we have computed, and after substituting, we can compute for the R value, which is 0.99. So to interpret it, if you're going to look at the size of the correlation, since it is 0.99, so it lies under the very high positive correlation. Therefore, the relationship between the age and income of the respondents is very highly positive. Thus, as the age of the respondents increases, their income also increases. Thank you for watching.